Okay, in this video we are going to be doing 21 exclusively Calc BC multiple choice questions. Let's get started. So question number 1 is from 2003, it's number 5. Let y be the solution to the differential equation dy dx equals x plus y with the initial condition f of 1 equals 2. What is the approximation for f of 2 if Euler's method is used starting at x equals 1 with a step size of 0.5? So every Euler's method problem, I set up this table. You can actually, I guess it depends on the problem. You can fill in the x column like right away. I mean, we know the initial condition is 1, 2. We know our step size is 0.5, so you're going to just keep adding 0.5 to x in this case. Watch out, by the way, on the exam for negative step sizes. It happens. Now we've got to calculate dy, and dy is going to be delta x, which is 0.5, times the derivative evaluated at the current point. So the current point is 1, 2, so we're going to do 1/2, and then 1 plus 2 is 3. So that's 1.5. We add that to the current y, which gives us 3.5. And now we repeat the process as many times as we need to. So we're going to do delta x, which is 0.5. And then the sum, we're plugging our current point, 1.5, 3.5, into x plus y. So that's 5. So that's 2.5 plus 3.5 is going to give us 6. If this is free response, which it's obviously not, we have to make sure that we write f of 2 as approximately 6 and not actually 6 because we are only estimating it. But anyway, that's our answer. Let's look at the next one. So we've got the position of a particle moving the xy plane is given by the parametric equations x equals t cubed minus 3t squared and y equals 2t cubed minus 3t squared minus 12t. For what values of t is the particle at rest? Okay, so you have to be really careful here. This is not a question about dy dx. It's a question about dx dt being 0 and dy dt being 0. So first, we'll find dx dt. It's just a power rule. Took the derivative, factored it. So we now know dx dt is 0 when t is 0 and t is 2. But don't just jump in and select an answer. First of all, you can't select 0 and 2. We got to make sure that dy dt is also 0, and we're not just moving vertically at this time. So dy dt is also just the power rule. And then we have to factor it, so we get 6, the quantity t minus 2 and t plus 1. Set that equal to 0, and we get t is negative 1 and t is 2. Now we have to look through and find any time that shows up in both dx dt is 0 and dy dt is 0. So you can see t equals 2 is the only thing that shows up. That's our answer, which I guess I forgot to circle. Let's look at the next one, apparently. The Maclaurin series for 1 over 1 minus x is the sum from 0 to infinity of x to the n. You should definitely have that memorized. Memorize that one, memorize e to the x, memorize sine of x, memorize cosine of x. Going into the exam without those memorized is a really bad idea. All right, so we have this. Which of the following is a power series for x squared over 1 minus x squared? People tend to make this type of problem way harder than it needs to be. What I'm going to do is first I'm just going to write out some terms of 1 over 1 minus x. Now, look at x squared over 1 minus x squared. We can break that up, just kind of like factoring it a little bit, into x squared, and then the quantity 1 over 1 minus x squared. When you're dealing with 1 over 1 minus x, you want to just look for something that looks like it, so you can direct substitute into it. So now what we'll do is keep the x squared on the side, and we're going to substitute in x squared for every x that we see in our series above. So we're going to end up with 1 plus x squared squared is x to the 4th, x squared cubed is x to the 6th, and so on. Then if we distribute this, you could look at the answer choices right now and choose your answer. But if we distribute, we end up with x squared plus x to the 4th plus x to the 6th, etc. You look at the answer choices, it's definitely C. All right, let's take a look at the next one. So we're going pretty quickly, but these are review problems at this point because you're studying for the exam. You can always slow it down. You can always watch it again. Number 4 for us. The length of a curve from 1 to 4 is given by the integral from 1 to 4, square root of 1 plus 9x to the 4th. So that form right there is arc length of a function. If the curve contains the point 1, 6, which of the following could be an equation for this curve? Honestly, you can use 1, 6 in this problem to bump out C and D, I think, right? Because if you plug in 1 for C, you get 7, and if you plug in 1 for D, you get 5. But I'm going to pretend it's like a better question than that, and kind of keep doing it. So here's our arc length formula. Crucially, we have that f prime of x squared, f prime of x quantity squared. So we actually looking at it and just comparing, we can see that f prime squared is 9x to the fourth, which means we kind of have a situation. F prime is either positive or negative 3x squared. So we have to like decide between them. But again, we already could have bumped out C and D. So at this point, we know the answer is basically B because we have to integrate this thing. But let's play it through. So we also, I guess at that point, we know that the answer is not A. So we know the answer is B. It just has to be. It can't be A because we have to integrate. They're like trying to get you to forget to integrate, I guess. So we have to go through 1, 6. So we cross those out. If f prime is 3x squared, then f of x is x cubed plus c. Then we can use our ordered pair, and we can say that 6 is equal to 1 plus c, so c is 5. That's kind of the authentic way to get b, rather than like just using test-taking strategies. But honestly, on the exam, do whatever you got to do. Next question. We've got a function f has Maclaurin series given by x to the fourth over 2 factorial, plus x to the fifth over 3 factorial, x to the sixth over 4 factorial, ... Then we have x to the n plus 3 over n plus 1 factorial. So when I'm doing these kinds of problems, what I focus on immediately is the factorial, because the functions, the Maclaurin series that you have memorized, they all have different denominators, right? So e to the x has just n factorial, sine has the quantity 2n plus 1 factorial, and cosine has the quantity 2n factorial. So when I just see n plus 1 factorial, I'm thinking this is probably just e to the x somehow. So now I want to rearrange it so that it looks like e to the x. So I'm going to take this nth term, the x to the n plus 3 over n plus 1 factorial, and I want to get it to be like x to the u over u factorial. So I'll take out an x squared, and I have x squared times x to the n plus 1 over n plus 1 factorial. That looks exactly like the nth term of e to the x. It may not be how you have it memorized, but as long as it's x to a power over that power factorial, you're good. So what I'll do now is I'll write out the terms of e to the x, because I'm pretty convinced this is e to the x somehow at this point. Like, I think the answer is C or D. I would have to be, I'd have to be shown that I'm wrong to admit defeat on that. So e to the x is 1 plus x squared over 2 factorial, etc. So if I take this and multiply it by x squared, the reason I'm choosing to multiply by x squared is because I said the nth term was x squared times this thing. So I mean, at this point, I think I can just choose C already. But if I did that, multiplying through by x squared just increases the exponent of every x you see by 2, and 1 times x squared is x squared. So you get 1 times x squared is x squared, x times x squared is x cubed, etc. So now we have this. Compare it to what we were given, and it's not exactly right, but if I were to subtract x squared and subtract x cubed from what I currently have, I would have what I was given. So I think that our function, by knocking off those terms, is x squared e to the x minus x squared minus x cubed. So I would pick C. So there's a lot of different things to think about as you do these. I think looking at the denominator, that factorial, is really key to deciding which of the functions you're probably manipulating. And they're not really trying to trick you on the exam, so like the one that you're probably manipulating is probably the correct function. Let's take a look at the next one. So the number of moose in a national park is modeled by the function m that satisfies this logistic differential equation. You got to memorize the logistic differential equation. You don't really need to know its solution. You do need to know that you need to know the limit. You need to know when it has a point of inflection, and you need to know that you can take values and plug it in. But here, we're looking for the limit as t approaches infinity of m of t. So this is written out exactly how I have it memorized. L is definitely 200. So that's our answer. Make sure you memorize the logistic differential equation, like free points. If it's on the exam, it'll just be free points as long as you have it memorized. Let's take a look at another one. What are all values of p for which the infinite series, the sum from 1 to infinity of n over n to the p plus 1 converges? So because you're going to infinity, what you can do to just think about convergence, I mean, I'm sort of on some level using the limit comparison. I'm just going to say that if we go to infinity, then n over n to the p plus 1 is basically the same as just n over n to the p. And then if we do some algebra on that, that's just 1 over n to the p minus 1. So now we've kind of turned this into just a p series that we would compare it to. So I'm thinking of limit comparison, but I'm using that to kind of motivate what I'm doing. So I know that this would converge as long as p minus 1 is greater than 1, right? That'll be a convergent p series. So as long as p is greater than 2, this thing will converge. So our answer is D. All right, let's take a look at another one. So we've got the integral of x sine of 6x dx. This is integration by parts, like classic integration by parts. So we need to pick a u and a dv. In this case, or actually in general, you want to try to pick u so that the derivative eventually goes to 0. So polynomials are a really good choice. So u is equal to x, and then dv is everything that's left over. So sine of 6x dx. And then we'll find du, which is just dx. And then v, we have to integrate. Remember, you're going to get cosine, so you pick up a negative. And you have to remember the chain rule. So we're going to get v is negative 1/6, and then cosine of 6x dx. So we start to like form our answer at this point. So it's going to be uv minus the integral of v du. So I'm going to write u times v, and then minus, which becomes plus 1/6, and then the integral of cosine of 6x dx. Now we just have to integrate that. So, there should have been a 6, so you get another 1/6 and then a sine of 6x. So this is what our answer ultimately will look like. Honestly, if you look at the answer choices, as soon as you got negative 1/6 x cosine of x, you could bump out A and D as answer choices, and then you just have to choose between what's left. So our answer here is B. All right, let's look at another one. So we want to know which of the following series diverge, so not converge, but diverge. So looking at the first one, we have sine of 2 over pi. That feels like a geometric series to me. I know that sine of anything is in between negative 1 and 1. So what we're dealing with here is a number between negative 1 and 1 divided by pi. So that's going to give us the r for our geometric series is less than, well, the absolute value of r is less than 1. In actuality, r is less than 1. But the absolute value of r is less than 1, which means this is actually a convergent geometric series, so it does not diverge. If you look at the answer choices, 1 shows up in all of them except for C, so the answer is definitely C. Bad question, I don't know. There were 5 answer choices, and I took 1 away to make it conform to the modern version of the exam. But still, the answer has to be C. Let's go through and look at them anyway, because we're trying to review for the exam. So for number 2, I would say this is a P series where P is equal to 1/3, which is less than 1, so you diverge. And then for 3, I find people mess this one up the most because the easiest test to use for divergence is the one everyone forgets. If we just take the limit to infinity of e to the n over e to the n plus 1, we get 1, which is not 0, so this definitely diverges. So we can also get the answer, but knowing that 1 converges meant we knew the answer instantly. All right, let's look at the next one. We're at about the halfway point, but not actually. So this is looking at the answer choices. You can see this is definitely going to be partial fractions. Also, when you just have a factored quadratic, you're going to get partial fractions. So let's set it up. So we have a over x plus 2 plus b over x plus 1 is equal to 2x over the quantity x plus 2 times x plus 1. I'm going to use the cover-up method. So I'm going to let x equal negative 2, and that will solve for a. So what you do is you cover up the x plus 2 and plug in negative 2. So plugging in negative 2 to 2x gives negative 4. Plugging in negative 2 to x plus 1 gives you negative 1. So we get negative 4 over negative 1 is just 4. Then we do the same thing with x equals negative 1 to solve for b. So cover up the x plus 1, plug in negative 1, you get negative 2 over positive 1, which is just negative 2. Now we need to integrate. I mean, you can look at the answer choices at this point, I think, and see the answer. But again, do the work. Don't just rely on things like that. So we need to integrate this. This gives us 4 natural log absolute value of x plus 2 minus 2 natural log absolute value of x plus 1 plus c. So we get this as our answer. Let's take a look at the next one. So we're going pretty quickly. Again, this is review time, so got to go fast. This is not a strictly BC question, but I threw it in here because people do not practice this enough, and it's just absolutely free points if you know what you're doing. So we need the derivative of the integral from 0 to x cubed natural log of the quantity t squared plus 1 dt. So this is the second fundamental theorem of calculus, and what you're going to do is you take the upper bound and you sub it into the integrand. So the first thing we do is we replace every t that we see in the integrand with x cubed. So that'll give us natural log of the quantity x cubed squared plus 1. Then you have to remember the chain rule. So we're going to multiply by the derivative of the upper bound. So the derivative of x cubed is 3x squared. And that's our answer. I mean, I rewrote it, but you can definitely see that the answer is D. So don't forget the second fundamental theorem. It shows up on multiple choice. It shows up on the free response, but usually the upper bound is just x. So most people, even if they don't know what they're doing, will still get it right. Let's look at the next one. What is the coefficient of x squared in the Taylor series for 1 over the quantity 1 plus x squared about x equals 0? So I'm going to give you two different ways that you can do this. It's up to you which one you think is easier. So first, I'm just going to write a series for 1 over 1 minus x, which I have memorized. So we have this. Then I'm going to change this into a series for 1 over 1 plus x. So I'm thinking of it as 1 over 1 minus negative x. R is negative x or u is negative x. Every x that we see in the original, we're going to replace with negative x. That gives us this kind of this definitely alternating series. So 1 minus x plus x squared minus x cubed. The next thing I'm going to do, so this is where it gets a little wishy-washy. If I took the derivative of this, it's basically 1 over the quantity 1 plus x squared, except it's negative 1 over the quantity 1 plus x squared. So I'm going to do that. So I'm going to notice if I take this derivative, it gives me almost what I wanted. Now, if I take the derivative of my series for 1 over 1 plus x, by just power ruling my way through it, I get the derivative of this is negative 1 plus 2x minus 3x squared. Now, I don't want the negative of 1 over 1 plus x squared. I want 1 over 1 plus x squared. So I'm going to multiply through by a negative, which gives me this. And then I'm looking for the coefficient of x squared, so it's definitely 3. So that's one way of doing it. Another way of doing it, once you've gotten to 1 over 1 plus x, the series for that, 1 over 1 plus x squared is just 1 over 1 plus x times 1 over 1 plus x. So I could write down that if I do this is approximately, so it's not equal to this because I'm not going to infinity, but if I just peel off the first 3 terms of the series of 1 over 1 plus x, it's a quadratic. So I could just multiply 1 minus x plus x squared times 1 minus x plus x squared. The reason that I don't go to x cubed is that I'm looking for the coefficient of x squared, so any x cubed that's involved will automatically be too high of a power. Now I just have to multiply this out like Algebra 1 style, so I'm not going to make you watch that. I distribute the 1 to everything, then I distributed negative x to everything, then I distributed x squared to everything. Now I just need to search through here for x squared terms, here, here, and here, so you can see that we're getting 3x squared. The coefficient is 3. Either one of those methods is pretty useful. I would recommend that you know both of them. Just things you got to be able to do. Let's look at another one. Let p of x equal 3x squared minus 5x cubed plus 7x to the 4th plus 3x to the 5th be the 5th degree Taylor polynomial for the function f about x equals 0, which is also called a Maclaurin polynomial. What is the value of f triple prime of 0? Okay, so if you know what the coefficients look like in Taylor polynomials, you know how to do this, right? The coefficient of x to the n, well, really x minus a to the n, is the nth derivative at a over n factorial. So for the third derivative, I would just start off by writing the third derivative at 0 divided by 3 factorial is equal to, and then the coefficient of x cubed in the polynomial, which is negative 5, and then 3 factorial is 6. So I think we can say that the third derivative is negative 30, and choose our answer. So just make sure you know the general form. The series questions are never that bad. If I had to say, like, I don't know, I think maybe some of the polar type questions might be a little harder than the series questions. I don't know. I just don't think series is that bad if you have everything memorized and you really like practice. New problem. Let R be the region between the graph of y equals e to the negative 2x and the x-axis for x greater than 3. and we're looking for the area. So this is going to be an improper integral because we're going from 3 to infinity, because e to the negative 2x does not have a 0. If it had a 0, we would be like contained, but this is just going to keep going forever. So if this was free response, you have to really watch your notation. So I'm going to watch my notation throughout. You have to rewrite this using a limit. So we would rewrite it as the limit as b approaches infinity, the integral from 3 to b of e to the negative 2x dx. Now, proper limit notation throughout, I'm going to keep the limit. I'm going to do find the antiderivative. So e to the negative 2x, there should have been a negative 2, so negative 1/2 e to the negative 2x. And then we're going from 3 to b. Now we sub in b, so we still need a limit because there's still a b. And I'm just going to rewrite it without the negative exponent. Oh, I forgot the 2 there. That should actually be 2b. Not going to impact it because the limit of 1 over 2b, e to the 2b versus 1 over e to the b, they're both 0, but that should really say negative 1 over 2 e to the 2 times b. And then when you plug in 3, you get, so the plus is coming from, let me go back. You plug in b, and then it's minus negative 1/2 e to the negative 6, but I decided to write that as plus 1 over 2 e to the 6th. And then if you go to infinity, the b thing goes away, you just get this. So our answer is, I think, A. All right, let's look at another one. Which of the following series converges for all real numbers x? So I think that for a problem like this, what you can kind of do is like pick values and plug them in and see if you get something that converges. If you don't get something that converges, like you're done, you can cross it out because it would diverge. So for example, in B, you can see if you just let x equal 1, you get a p series where p is 1/2, which is less than 1. So that definitely diverges. Unfortunately, that doesn't really work on any of the other ones, at least not like obviously. So then I start thinking like, all right, I see that n factorial, which means maybe this thing is just e written kind of funny. And because it's e to the n and x to the n, we can make that the quantity e times x to the n. So we're looking at the sum of the quantity e times x to the n over n factorial. That's actually e to the x with ex plugged in. This is a series for e to the ex, which definitely converges for all real numbers because you're just substituting into a series that converges for all real numbers. This is our answer. If you don't see that, this question could be really time consuming. I guess I would just do the ratio test on everything. So I'm not gonna like do that, but here would be the work. This one I just want you to know if you're like really doing all the work, this will converge at the endpoints. This actually converges like absolutely at the endpoints. And then for D, if you do it, you end up with the limit as n approaches infinity of n plus 1 times the absolute value of x. So that actually only converges if x is equal to 0. Otherwise, you just have something times n, and n is spinning out of control, right? So this only converges at x equals 0. So we knew the answer was C. I don't really have a very clever way of doing that problem other than, observation and being willing to use the ratio test. Also, once you find the answer, you don't have to keep looking at the answer choices if you're confident. So let's look at the next one. What are all values of x for which the series 2 over, the quantity 2 over x squared plus 1 to the n converges? So this one I do have sort of a clever way of doing, and it's sort of the same thing that I did last time. Look at the answer choices, and you can see there's like between -1 and 1, greater than +1, less than -1 and greater than 1, or less than or equal to -1 and greater than or equal to 1. So my first thought is if I just let x equal, if I let x equal -1 and this thing converges, then our answer is D. So I'm hoping the answer is D. So I'm going to test x equals -1. But if you plug in x equals -1, you get 2 over -1 squared is 1. You get 2 over 2. So you're just doing the sum of 1 from 1 to infinity. That definitely diverges. So the answer is not D. So we can get rid of that. And it wasn't as cool as I wanted it to be. The next thing I'm going to do is just test x equals -2. Because x equals -2 is kind of definitive in this case. So when you plug in -2, you end up with 2 over 5, that quantity to the n. This is a convergent geometric series. So the series converges when x is -2, which means the answer cannot be A because -2 isn't in that interval. The answer cannot be B because -2 is not in that interval. The answer must therefore be C. And that's our answer. Now, if you wanted to do the work instead of just plugging, I'm not saying that that's not the work, but because it was multiple choice, we were able to do this. If this was like free response, we'd have to show some work. So I would say this is a geometric series with just a super weird ratio, right? So I would start off with the absolute value of r is less than 1, and then you solve through, you end up with this quadratic, you factor it. There you go, there's your answer. So we're greater than 1 when x is less than -1, and when x is or greater than 0, which consequently is less than 1, for the answer that we chose. So you can do the work, but also keep in mind it's multiple choice. It's designed for you to look at the options, right? So let's take a look at the next one. Got a couple more. What is the sum of the series 1 plus natural log of 2 plus the quantity natural log of 2 squared over 2 factorial? So one thing you can do if you're not sure what's going on is take the thing that's repeating, the natural log of 2, and replace it with x and see what series you end up with. And if you do that, this is all over this, and maybe e to the x is more common than the other series on the exams. I don't really think so. But I also see the n factorial. Everything about this is screaming e to the x. E to the x is 1 plus x squared over 2 factorial, etc. This is the series for e to the x with natural log of 2 plugged in. So we're definitely getting e to the natural log of 2. Then we just have to remember that e to the natural log of 2 is 2. All right, next problem. Okay, next up, problem 18. The table gives values of f prime g and g prime for selected values of x. If the integral from 0 to 1 of f prime times g dx is equal to 5, then what is the integral from 0 to 1 of f times g prime dx? This is integration by parts again. Anytime you see something weird like this, it's almost certainly going to be integration by parts. So we'll pick a u and we'll pick a dv. I think in this case we kind of have no choices. U is f of x and dv is g prime. Then we find our du and our v, but in this case, because it's purely notational, this is actually an easier problem. I think a lot of people are intimidated by these, but I would say they're easier because there's just less for you to screw up. So now we're just going to do uv minus the integral of v du. So uv minus the integral of v du. Don't forget the bounds, which you can see that I have forgotten on the integral. So f of x, g of x from 0 to 1 minus the integral from 0 to 1 of g f prime of x dx. Well, they gave us g f prime of x dx, the integral, that's 5. We just have to fundamental theorem this first part, and it's not hard, but it's definitely a place that things could go wrong. So we have f of 1, g of 1, and then minus f of 0, g of 0, and then minus this value they gave us, so just minus 5. All right, now we need to use the table. So at 1, we get 4 and we get 3. So it's 4 times 3. And then at 0, we get 2 and -4. So that's 2 times -4. And minus 5. So we're going to end up with 12 plus 8 is 20 minus 5. So we're going to end up with 15. So don't be afraid of those. They're, as I mentioned, I think they're actually easier than when it's like x times sine of 2x, where you could screw up your positives and negatives and chain rule and all that. This is pretty straightforward. Next question. So if f of x is x times sine of 2x, which is the Taylor series. So I call this like building the series. I always just start off with the one that I memorized. So I have sine of u memorized. So I will write down that. Then what I'm going to do is I'm going to replace every u that I see with a 2x. So I now have sine of 2x is 2x minus 2 cubed x cubed over 3 factorial, and then 2 to the 5th x to the 5th over 5 factorial. Now I'm going to take this series, take everything I see, and just multiply it by x. So the impact that has on the series is that all the exponents go up by 1. And then because we have to match our multiple choice, I'm going to expand my 2 to the powers as well. So 2x squared minus 8x to the 4th over 3 factorial, and then 32x to the 6th over 5 factorial. 5 factorial. I don't know, it's confusing when you're reading them. I think the answer here is D. All right, we got 2 more problems. Number 20. So this is a BC level question, and just it's from 2008, and I just have so many memories of students finding this question very difficult, and I honestly think this is a pretty difficult multiple choice question. Feels like it has a lot of parts. In the xy plane, a particle moves along the parabola y equals x squared minus x with a constant speed of 2 root 10 units per second. So it's not obvious at first that this is a parametrics question, but I'm pretty sure it is. If dx dt is greater than 0, what is the value of dy dt? So I think a lot of people think, oh, related rates. I'm thinking parametric specifically because of that speed thing that they gave us, right? So speed for parametrics is the square root of dx dt squared plus dy dt squared. So they're basically telling us that the square root of whatever is equal to 2 root 10. We can square that and get that dx dt squared plus dy dt squared is 40. That's an equation. Now, we can also go to y equals x squared minus x, and we can actually use implicit on this, or think of it like related rates, right? So take the derivative with respect to t of both sides of y equals x squared minus x. We get dy dt is equal to the quantity 2x minus 1 dx dt. This is important because we actually know the speed is constant, and we're interested in the point when x is 2 and y is 2, right? So we're interested in that point. So we can plug in 2 for x, and it gives us this relationship that dy dt is just 3 dx dt. Now what we can do is combine these, because we know both of these, replace dy dt with 3 dx dt, and we're going to end up with dx dt squared plus, remember we're replacing, so it's 9 dx dt squared. So that's 10 dx dt squared is 40, or dx dt squared is equal to 4. We know that dx dt is greater than 0, so that means dx dt must be 2, because we knew that we were positive. Now, if you go back to this, dy dt is the quantity 2x minus 1 times dx dt. We found dx dt is 2. We know that we're at the point 2, 2, so x is 2. So we're just going to plug in for x, we're going to plug in for dx dt. We get dy dt is 3 times 2, which is 6. I think that's a tricky question. I don't know. It has stood the test of time. Let's look at the last problem that I decided to do in this video. If the sum from 1 to infinity of a sub n diverges, and a sub n is less than b sub n for all n, which of the following statements must be true? So this is basically the setup for the direct comparison test. So I think we're doing direct comparison. If the smaller series diverges, the bigger series must diverge. If this bigger series converges, the smaller series must converge. This is kind of how they ask about direct comparison on the AP exam, so make sure you're comfortable with this kind of question. Also, you can see I formatted D incorrectly. I think it's the only thing in the entire document that I screwed up. But one of the things that I like to think of is just like a graph, right? So if this is what a sub n looks like, then b sub n is bigger. And you can just see like the terms of a sub n are pushing the terms of b sub n bigger, and a sub n already diverges. B sub n has to diverge. All right, so that's it. That is 21 additional multiple choice questions that I hope will be useful to you as you study for the AP exam. I hope this was helpful, and good luck.